The day of reckoning has come upon us. Plankton has stolen SpongeBob's brain and put it into a robot. There is only one thing Mr. Krabs can do: fight fire with fire. The biggest obstacle is right at the start. How are we going to get the fetch robot working in the Swift environment, which it definitely was not made for? First, it was a scavenge for the parts, going into ROS examples to locate the files that make up the robot, and then by plugging in those files into Blender and extracting the poses, we were able to replicate it in Swift. Except when it tried to move. So we tried to create DH parameters for it, and failed for 6 weeks. The robot was just too complex. And then we looked into the robotics toolbox. McCork, you've done it again. Now the URDF wasn't perfect straight out of the box, so there had to be some changes, but once that was done, we had a working robot in the sim. Then we designed the mount for the spatula that will fit over the gripper like the Ben 10 Omnitrix, which could be 3D printed. Never mind, my printer's in my room and I don't want to hear while trying to sleep. This is a patty. And to get it cooking, we had to go into the Swift library and add this line, and now it changes colour. So now we input the pose of this patty, and the robot uses inverse kinematics to move its end effector to the position of the patty. Add a couple of offsets, and now we're cooking. Kinda. It's time to integrate collision detection. What we do is we create boundary boxes, showcased in grey, of where the robot should not go under no circumstances ever enter the vicinity of. Basically, the inverse kinematics are re-rolled until each of the links do not intersect with these grey boxes. For some reason, the robot really wants to hit the wall as it moves in a circular form due to the way the Q values are defined in the URDF.
I can see what they're doing, what he's doing. I can see it, I feel it. He's cooking.
Oh, okay. Well, good thing we have an emergency stop button. Our GUI also has a go button and a reset button to manually control the joints of the robot. And you can also feed the interface pictures of patties, and it uses machine learning to detect them and send them straight into the simulation. So now we've got the fetch cooking, it's time to put the UR3 to work by assembling the burgers together. The UR3 will hold out the plate awaiting for the fetch to place the patty onto it. Once the patty's placed, the UR3 will put the plate on the table. By using RMRC, the robot is able to pick up the tomato sauce and place it on the burger in a circular fashion. And finally, the plate is given to the customer who ordered a burger patty with tomato sauce on it. Now the future possibilities for this robot are endless. In fact, robots like this already exist in some type of way. With enough training and determination, these robots will eventually be able to make Krabby Patties. In the end, once we've ironed out the kinks, used Gazebo instead of Swift, this is just an open letter to the faculty to let